Okay. So everybody can see that?
Yes.
Okay. I found my new favorite Slides Go and they have templates. I used a template that included like a petroleum background. So I'm so excited about that.
Where was that from?
Slides Go.
Okay.
Yes, you do have to, acknowledge them in your presentation, but they have all kinds of cool templates.
Nice. Okay.
I stole one.
Love
So
that.
the just the parts to and then my introduction. We did simulated a fracturing process or fracking, and it's a technique used to extract oil from underground, and it involves pumping fluids into a rock bed, mostly shale, at high pressures to break the surrounding rock to create pathways for that fluid to flow, and help the trapped oil get to the surface. So and the process involves, prepping the site, which is clearing of the land, digging, the construction of the well pad, and then the actual drilling of a well bore into the ground. And the key is to get below the water table or any aquifers. And then once it's underground, it's to extend it horizontally through the rock layer. And then the well bore is cased with piping, and then it's filled with cement to basically seal off the well bore to prevent any contamination with the groundwater or the aquifer system. And then the key is in the wellbore to put holes, which they call perforations, to provide access for the fluid to get into the oil-bearing rock, and then pumping the fluid into the wellbore, forcing it out of the perforations into the surrounding shale or rock, which creates fractures in that rock, which in essence creates a pathway for the hydrocarbons to flow. And then the final part is the flowing of the oil to the surface so that it can be collected and used. So the problem was an engineering scenario. So the first problem was to design and simulate and then evaluate the wellbore configurations to optimize the fracturing process. And then the second problem was to successfully fracture a given formation to make contact with the oil. The constraints, like everybody said, was the materials, the color of the gelatin, which I found out, the firmness of the gelatin that we use to simulate the environment, the size of the container, the size of the syringe that we used, the actual creation of the wellbore and getting that into the jello or gelatin, and the sealing of the straw because there could be leakage. Um, and the second part was the brainstorming and in an effort to save time, I purchased the gelatin because I heard someone say that in when we all met on that Monday that they purchased gelatin. You can see that the container is smaller than the recommended container, and of course it has color in it, which is going to make it more difficult to see. And then I got different types of straws. I got the clear drinking straw. I got the tri-colored smoothie straw, and then I got jumbo straws. You can see the yellow and the blue. And then the first thing is to, in that first image there, this one, you can see that there is, in the process of putting the gelatin together, you have to put a straw in there and make a core that you can add vegetable oil, which is going to represent the hydrocarbons. I had difficulty in getting the core out. So I think it broke, and I think it was because the gelatin wasn't firm enough. So
Mm.
I did fill it with the oil. So there is oil and vegetable oil in there. And then about 3/4 inch from that core, I put my straws, which represent the well bores. And in those straws, if you can see, I have different perforations. So you can see here, I have three holes that went through the straw. So those were at an angle that went through. So it was a 360 degree. Is that right? When it goes through. So I had three on one side and three on the other. And then for this straw, I had one medium sized hole. And then here I had three, but they were at a 0 degree, meaning that they're all on the same side of the straw. And then for this straw here, the smoothie straw, I had seven perforations, also 0 degrees. So, well, 90 degrees because they went to both sides of the straw. So, in the process of the testing. So here I have my testing and my results. So I highlighted the one that worked the best. So I struggled a little bit because there were so many variables associated with this project. So the perforations were a variable, the injection speed. So you used do I have the image here? Where's my, so you used a syringe to inject. I don't see my syringe, but you used the syringe to inject into this. And I kept this constant. So the amount of syrup that I pulled up, it was dark corn syrup, which was thicker. I kept that constant. I kept my location from the well bore constant, or actually, I should say from the hydrocarbons. I kept that constant. And then you can see I kept the injection speed constant. So the two variables that I was changing were the perforations and the straw size. So for the jumbo straw, the yellow one, the syrup remained in the straw and there were no fractures because I couldn't get the syrup to get forced out of the well bore. And the same held true for the drinking straw, and I had a complete blowout on the jumbo straw, the blue one with the medium size hole, meaning that all of the corn syrup was forced out. And then I did have some fracturing present with the use of the smoothie straw. So what I kind of concluded was that the perforations and the location of the perforations affected the fracturing process. So, too small or too few of the perforations led to the corn syrup remaining in the straw, which held true for the yellow and the clear straws. And too large of a perforation in the blue straw led to a complete blowout. So the perforation count and the size of the straw resulted in small fractures in the tricolor, which is where I had some success. So my iteration was to use the one where I had the best result, which was the tricolored smoothie straw, and I added additional perforations, and it had better results, which is hard to see because I have color, but you can see the corn syrup that left the straw and went into the environment, but it didn't quite reach the hydrocarbons. So, so I had a positive fracturing process, but it didn't extend completely to the hydrocarbons. So my reflection and discussion. Um, So the reflection was that the size and uniform distribution of those holes or perforations were critical to the fracturing process because they directly affect the pressure and the even distribution of the fluid being forced out of the straw or the wellbore and into the surrounding shale environment, which is that oil-bearing rock, which is typically shale, which ultimately leads to the successful fracturing. And in the image, you can see that they have the perforations, and when the fluid is forced, it goes out into the surrounding environment. I also concluded in my reflection that the larger perforations, I have a misspell, led to a decrease in the pressure, resulting in less fracturing, and that the smaller perforations can lead to too much pressure, and result in a blowout. Um, and then my iteration, I added the additional perforations in a 90-degree fashion. I faced those perforations in the direction of the hydrocarbons, trying to get that fracturing to meet. And I kept the syrup and amount and flow speed the same. Um, Future iterations, I was thinking that I could decrease the syrup amount to maybe 10 milliliters and increase the diameter of those perforations to allow for less syrup remaining in the straw and more going into the environment. And that if I increased my flow speed, it would force more of that fluid out and create longer fractures, which could reach the hydrocarbons. Um, and then things to consider in the process and relating it back to the actual fracturing is that setup, and this was in discussion questions. So I kind of took those questions and made it a slide. That things to consider when in the fracturing process, that the setup leads to clearing of land and the degradation of that ecosystem, and that a lot of water is used in the process, and that consumption of fresh water reduces the amount available for the ecosystem. And that one thing that you have to really consider is that you want to case your wellbore in that cement and that piping to prevent contamination of the groundwater and the aquifers, and that disposal of the contaminated wastewater, it has a lot of heavy metals and things like that from the ground, and so that you have to properly dispose of that. And then once the well is abandoned, it goes dry, there should be restoration standards for restoring that land to what it was prior to the welling process. Improvements I could make would be to follow your suggestions, use clear gelatin, and to use a larger container. And I like, and a question I have is when you make that gelatin, do you plop it out of the container? It looked like in the image it was out of the container, but it's still in the container.
Yeah.
Okay.
Yes. It
Okay.
would stay in the container, like stay in the container and then you would see it from here. We used to do the first year we did it when this training was in person, we used like a loaf pan and we dumped it out and we did it and it was such a mess. So yeah, it should stay in the container.
Okay. And to increase the amount of gelatin to make the environment firmer and more rigid, which would be easier to work with. As I was doing the gelatin was melting, so it was starting to liquefy. So you have to be really cognizant of the time that the gelatin is out. And also, I was looking up other ways to improve, and it was to prepare it overnight, but to put that straw in there for the core. If you seal off the bottom of the straw and you put it in the wet gelatin and let it go around, it would be easier to create that hydrocarbon well.
I, that's a really great suggestion.
Yeah, so they took a straw, they sealed off the bottom of the straw, and then they put it in the liquid gelatin, and then they let that set, and then you can remove the straw and you have a bore.
Yeah. Yeah.
So
So instead of taking the jello out after it's made, you just like create a cavity prior to it setting and being
correct.
solid. Yeah. Love that.
And that was it.
Perfect. Amazing job. Thank you so much for this. You did a fabulous job. This was one of the projects that we also spent a lot of time reworking this year because when we looked at it, we had a lot of confusing terminology where we would say, and now you're using the jello and the straw to extract the hydrocarbons, right? So we were mixing like jello and straw, which are physically what they are, with the petroleum language, which is hydrocarbon, right? So it should have been like you're using the jello and the straw to get to the oil, or we would need to say, you got to have your rock formation with your well bore to reach the hydrocarbons. So we were our teacher notes and our student handouts were like all over the place, like mix and matching terminology. So we spent a long time this year trying to like rework it so that we were really consistent in like the language that we used throughout, and then also just providing clarity on the different steps. And so I'm really happy to see that it made sense. And I think that the conclusions that you came to were exactly, kind of what the students are going to see. So the bigger holes, there's not going to be enough pressure for the oil to get out. Like you're going to push it down and the oil is just going to kind of like trickle out because the hole is too big. Or sometimes you don't even push the syringe and the oil or the syrup is already, leaking out. Though when the holes are too tiny, you have what you experience, which is that the oil can't even get out because it's stuck. And especially, when if you use like say a push pin or something, then you've got the little plastic from the straw, which is actually making the opening even smaller, right? Because when you push that pin through, the outside hole looks big, but the inside, it's like when you have those drywall screws, the inside hole is small, but it doesn't ever expand out. Um, and then, yeah, the direction of the perforations, if you have it all around the straw, you're going to have more chance of contamination, right? So, like if you directionally point it towards where you're trying to reach, that's where the fracturing will happen. The thickness of the jello, so obviously, if you're using the Jello cup, it's pre-made Jello. But if you are making the Jello yourself, it does have recommendations in the slide or in the teacher notes, excuse
Mhm.
me, um, to like not follow the like amounts of water and gelatin, but to do, I think, 3 packs of gelatin for 4 cups of water. So like it does have a recommendation, and that does help make it a little bit thicker and that helps with a little bit of the melting piece of, of the project. But again, that's if you're going to make your own. If it's already store bought, then you just got to work a little quicker, quicker. So basically, Jello stays in the fridge. You figure out the straw configurations and then go from there. And then you also mentioned that there were a lot of variables, which is a very astute observation. So, if you have a small class, you could say like, okay, everyone's using the same size straw, like that's coming out of the equation. Or you could say, I want everyone to use the same injection speed, just to have a little bit of consistency and to remove some of those variables. It could also be applicable if you have like a really big class that you want to eliminate some of the variables. That is totally up to you guys. And it could also be a limitation of your supplies, right? Like maybe you only have one size straw that you, you brought in. Typically, the skinny straws, like the regular size straws, tend to be too small. You can't get the oil, like you can't get enough of the syrup in there, and then you're injecting it and it's hard to connect the syringe to it. So if you are only going to get one type of straw, I would definitely recommend like the smoothie straw size or somewhere, like the jumbo slash smoothie sized straw. So, but the more that you limit the supplies and guide them towards what will maybe ultimately work best, then the less, conversations you have. Like I loved everything about your slides that you had, this happened with the small one. Like you tried so many different combinations that you really got to see, a lot of what we're trying to get the kids to see it, to have those discussions. What I would say to definitely avoid doing is assigning groups specific configurations, right? Like that's the work that we want them to do, to think about it and to think like, well, why do I think, I think the small holes are going to work best because, it'll help keep the oil together and that, or the syrup, contained in the straw. And then they're going to test it and they're going to realize, oh, well, it's maybe too small, right? So we want them to, when they're picking their designs of their well bores. And so, Jen did, was it three or four different straw designs, I think.
Four.
Um, that would be like four different people on the team, right? Would each have one straw to design, right? And when they're doing the brainstorming, part of the brainstorming is like, why did you make your choice? Right? Why do you think a big straw with medium perforations all around your well bore is going to be most effective, you know? And so trying to tease that out of them and not just saying like, okay, well, I'm just arbitrarily going to pick things, getting them to try to think about why they think it's going to be successful. And then when they test it, realizing, maybe it's not. And then in the procedure, the way it's written is that what Jen did is kind of like day one, right? You test four different methods and you see which one might be best. And then day two, which is, I don't want to say it's optional, but it's kind of like the final test day where they say, okay, we tried four different things. Let's figure out which one worked best. And then we get to actually try it and really like get to the wellbore in a clean, contained environment where there's only one wellbore going in, truly trying to reach the hydrocarbons. So again, the purpose of the second day is really to say, okay, this one worked best, let's test it in a nice clean environment and see if we can get that replicated result of the best option. um
Vanessa, question.
yes.
Could you, number one, make the gelatin containers ahead of time?
Oh yeah, yeah. I mean, you
Okay,
should, yeah, you
good.
should definitely
Okay.
make them ahead of time. And I think Haley said it on the call, or someone said it on the call, that she makes her kids make them and bring them in,
Yeah.
which
Yeah.
is a great option. But yes, I mean, if you're not buying the prepackaged gelatin, you would want to make those, a couple of days in advance. And again, depending on your class size, you gotta have a teacher fridge where you can store, uh 10 things of gelatin. But yes, yeah, definitely would want to make those ahead of time.
And could you not assign them the configurations, but could you assign groups a straw?
Yeah.
One group gets the drinking straw, one group gets a jumbo straw, one group gets the smoothie straw, and they have to do their perforations and do all of that. But at least for that one group, you're holding the straw constant
Yeah.
and then they compare as a class.
Yeah, I think that's a great way. So, you could, yeah. You could definitely constrain the straw size to like a group so that they're all comparing, like you said, so that they can maybe try to isolate what is contributing to their success or their failure. And then have that big group discussion, like, everyone who had the small straw, none of their designs work, or the small straw. And the thing you could find too is like the small straw might work with bigger perforations, right?
Mhm.
Whereas the smoothie straw might work with smaller perforations. So yeah, all sorts of really good discussions that you can have with your team
Yeah.
um, about that. So yeah, yeah. Other questions? All right, perfect. So Brandon Burrows, submitted his assignment on LTP, but I'm actually not able to see it. I think it might have to do with the fact that it was an MP4 and for some reason it was not an accepted file type. So I'm not able to open his presentation and he had to hop off to a doctor's appointment. So what I'll do is I will post the video of him going over his slide deck. And then I'll on Monday make some commentary if there's anything that I want to add based on his presentation, but I will make that available for everyone to also watch. So I think that was a really great presentation. I would encourage you just from a slide presenting thing to use animations to try to make things come in one at a time rather than having everything up on the slides all at once. But I did love, I was just looking at the slides go stuff. That's a great resource for some really cool templates. So, all right, excellent. Let me stop the video.